The figure above shows two charges Q1 and Q2 held a fixed distance d apart. Assume that Q1 and Q2 equals to 15 microcoulomb and d is equal to 2 meters. If a third charge Q equals 15 microcoulomb is brought in and placed as shown in figure B, what is the strength of the electric force on Q1, Q1, Q2, Q3? So from here to here is D. So if we divide this by 2, we have D over 2, D over 2. This is D, this is D. So it's basically an equilateral triangle. So this angle, 90 degrees with this perpendicular bisector. So it is 90. Here will be 60 degrees. Here will be 30 degrees. And 60 degrees. So let's call here X. Let's call here X. So from Pythagoras theorem, d squared is equal to x squared plus d over 2 squared. X squared is equal to d squared minus d over 2 squared. So x is equal to square root of d squared minus d over 2 squared. So if we put in the values, d here is equal to 2 meters. D is equal to 2 meters. So here will be 1 meter. Here will be 1 meter. So if we put it here, it will be square root of 2 times 2 is 4. 2 squared is 4 minus. This thing is 2 over 1. Is 2 over 2 is 1. 1 squared is 1. So it's square root of 3. And is equal to 1.7321 if you like. So magnitude of electric force F vectorially is given as K Q1 Q2 all over arrow squared 1 2 times a unit vector 1 2. Since all these forces have the same charge of 15 microcoulomb, it means that at this point there will be a repulsive force from 3, and also from 2 there will be a repulsive force. So they will act this way, of which we can find the resultant. So this is the resultant. So this one is F21 and this one is F31, F21. So this now is equal to F31 plus F21 force on Q1. So in order to do it vectorially, we'll now say it is equal to, let us do this one first. So the distance between here and here is D. We say K Q1 over D squared, because unit vector R12 is equal to the vector 1 2 over the magnitude. So that's the unit vector. So the unit vector will be, from here going this way is negative minus x I hat, plus from here going up is positive d over 2j hat all over the magnitude of this vector is square root of minus x squared plus d over 2 squared, then plus, and I do for this f21. This f21 is off from here to here straight and it's positive, so it is kq2 q1, if you like, over the distance from here to here is d squared, half plus half, d over 2 plus d over 2 is d squared. So the unit vector for this one now is just straight along the y-axis, and it is the vector is dj hat all over d magnitude, or you can just say of course d magnitude is equal to square root of d squared, which is d, so we have leave it as d. So we now factorize, since q1, q3, q2 are the same, so we just have kq squared over d squared into, if you like, this thing now, this thing is this, because from Pythagoras the square on this is equal to the sum of squares on this other two sides of this hypotenuse. So it's just minus xi hat plus d over 2j hat all over d plus k q squared over d squared times dj hat over d, because the magnitude of a number is also a number, so you have it that way. So we now have, let me, kq squared over d squared into, if we do j, we have minus xi hat plus d over 2 j hat, this and this. We have factorized out, so that if we now put the numbers, we have, is equal to 9 times 10 raised to the power 9 for k. Then for this, we say is 15 microcoulomb, 15 times 10 raised to the power minus 6 squared into x. We have found x to be 1.7321. 1.7321. D is 2 meters. So D is 2 meters. We actually have D plus this 1.5 D, that's 3 over 2D plus, but let me just do it naturally. So we have plus 2 meters. This is minus front here because of this minus. Then plus 1 meter, 1j, 2j, I hat, j hat, j hat. Okay, all over d cube, because this d cube is 8. If you factor these ones out, this is d cube, so you have this, that's 8, so that we will now have it to be equal to, if you multiply out this thing and multiply it with this one inside, you have minus 0.44 I hat plus, of course this time this plus this will be 3j, so you multiply it with this one, you have 0.76 j hat. So that is the answer, the force in vector form, because they are acting this way. So if we want to find the resultant, we now say it's equal to F is equal to square root of fx squared plus fy squared, and it will give us square root of 0.44 squared plus, of course, minus plus 0.76 squared, and it's approximately 0.88 Newton. So that is how to do this type of problem. Kindly subscribe and like the video. Bye.